In the previous lesson, you learned how this machine works and what inputs and outputs the machine has. In this lesson, I'm going to start writing a PLC program that can control the sequence that I need this machine to do for me. Okay, to get started, I'm going to add a flip-flop here. I'm going to use this flip-flop to run motor 1, so I'll enter the address of that motor here. As I said previously, when the start switch is pressed, the motor is going to run. So I'll add an open contact here in the set input and give it the address of the start switch. To turn the motor off, I need to use the stop switch. So, given the fact that the stop switch here is normally closed, and I want the switch to stay false during the normal operation, I'll insert a close contact here with the address of the stop switch. So with this simple piece of code, I can simply turn motor 1 on and off. Now, let's get to writing the code for counting the small red boxes. To count the number of red boxes, the first thing that I do is add a count up instruction in the next network with the address of CO. As I said, sensor 1 sends an electrical signal to the PLC every time that a box passes by, and that signal is used to count the number of red boxes. So, I'll add an open contact in the counter input with the address of this sensor. Every time a red box passes in front of sensor 1, the counter's accumulated value will be incremented by 1. Now, what happens next? As I said, when the number of red boxes within the blue box is equal to 3, 3 things should happen automatically and at the same time, which are: the signal lamp should light up, motor 1 should stop, and motor 2 should run. Let's start by writing the code for turning on the signal lamp, which seems easiest to do. I'm going to add an equal instruction in the counter output. I want this instruction to be true and let the signal pass when the counter's accumulated value is equal to 3. Now, where can I get the current accumulated value of the counter? Well, for that, I'm going to insert MWO in the counter value output to save the current accumulated value of the counter in this section of the memory. Then, I'll use the same address for the equal instruction. For the lower section, I'll enter 3 as a constant. Okay, now when the number of boxes passing in front of sensor 1 reaches 3 and allows equal instruction signal to pass, I want the signal lamp to turn on. So, I'm going to add a flip-flop here and assign it the address of the signal lamp. As I said, when the signal lamp is turned on, I need motor 1 to stop and motor 2 to run at the same time. To shut down motor 1, I'm going to add a branch in the reset input of this flip-flop, and then insert an open contact with the address of the signal lamp. Then, I'll connect this open contact to the reset input of the flip-flop. I can use the same approach to run motor 2 at the same time. I'll add an SR flip-flop in the last network and assign it the address of motor 2. Then, in the set input, I'm going to add an open contact with the address of the signal lamp. Okay, now let's walk through all of the code that I wrote here from the top to bottom. In the first network, I'm able to simply turn on or off the motor 1 using this flip-flop. In the second network, every time a small red box passes in front of sensor 1, the counter input is going to be true, and the counter's accumulated value will increment by 1. When the counter's accumulated value is equal to 3, the signal will pass here and light up the signal lamp to tell the operator that the big blue box is now full. When the signal lamp is on, the reset input of the flip-flop in the first network is going to be true, and that will shut down motor 1. Simultaneously, the set input of the flip-flop in the last network is going to be true, and that will run motor 2 automatically. In the next lesson, I'm going to complete this program, and then I will test it in the online mode to see how it actually works.